Okay, as I already said, I'm going to talk about web-based visualization of multidimensional linguistic annotation. And as you all may know, linguistic corpora are often annotated on several descriptive levels, like phonology, morphology, syntax, and so on. And when it comes to spoken language corpora or multi-modal corpora, often gesture or facial expression are also included. Having these multiple levels of annotations, it's very likely to have overlapping structures, and in dialogues you also have a great chance to have speakers' utterances overlapping. Fortunately, XML is powerful enough to deal with these challenging structures. There's an underlying graph model, and XML can represent graph structures by the XML inherent ID/IDREF mechanisms. It's possible to describe graph structures, and there's no restriction to single hierarchies. What this means will be clear later on. So there are many formats which can deal with multi-dimensional markup, like T milestones and fragments, the night format, serialization of annotation graphs, which focuses on multimodal data, or feature structures. I've chosen two standoff XML formats as starting points for possible visualizations, and these are XStandOff, meta-annotation format for textual primary data, and the XMRALA basic transcription format, which is used to store transcriptions and annotations created by the XMRALA partiture editor. This one is intended to work with audio or video data. So what I will do now is give a brief introduction into XStandOff. If you have textual primary data, you can have multiple levels to be annotated. For example, verse structure and direct discourse annotation. You don't see it at first glance here, but there's an overlap. You can't just merge these two into one XML document. XStandOff, however, can represent both annotation levels in just one XML file. It references the primary data. The primary data can also be inserted directly, and there are layers for the annotations, for example, verse structure and direct discourse structure, and by referencing segments of text spans, the annotations are linked to the primary data. So the first step was to think about a 2D visualization of multidimensional markup. The main goals were, first of all, an illustration of the relationship between primary data and annotations, and secondly, an illustration of the relationships between the annotations. This was also looking at potentially overlapping annotations and other tree challenging phenomena. But there's some lack in this visualization method, which will be tackled later on in another approach. But first of all, this approach was realized as an XSLT transformation of XStandOff into HTML, which was used to be a wrapper for an included SVG visualization. SVG was mentioned earlier today, and you all know SVG. There's been a brief introduction, so you know what's meant by this. So the creating of SVG for XStandOff mainly includes the possibility of switching annotation levels. This is the section including the SVG with segment bars representing the individual annotations, and these levels of annotations can be switched to the left or to the right, and there's also a highlighting of the relationship between primary data here and the annotations. Another feature is that classic overlaps can be displayed. For example, in this instance, there is, I don't see it now, but you will see later on if I give the online demo. There are certain problems with this visualization. For example, short annotation ranges. If you have an annotation just spanning this determiner A, it would be a very small segment here, and as you see, this is much longer than this text here, so you don't always have at first glance a relationship between the SVG and the primary data, but probably have to scroll to get these both aligned. Well, a possible solution to this problem would be a synchronized scrolling approach. It had not been implemented yet, but I will do it later on. And what has to be there is a minimum height for the SVG rectangle, and the scroll positions. Well, with this synchronized scrolling, I mean that the scroll positions of the SVG section and the primary data section should be synchronized, so we always see which primary data section is corresponding to which annotation. However, it's still difficult to get an overall impression of the annotation structure for long text. For example, if you want to visually explore discourse structure, you don't have the whole text, the whole annotation at one at first sight. This is a very short text, but if you have longer ones, you see you have to scroll. A possible alternative would be a 3D approach. I have investigated a method to realize such a 3D visualization. This is possible because there's native browser support for 3D graphics. HTML5's canvas element allows to render WebGL, and there's an XML format for defining 3D graphics, namely X3D. So it's possible to implement transformation scenarios based on XSLT for XML-based representation formats like extend-off, without even leaving the XML context. The basic principle of the 3D approach would be to order concurrent hierarchies. These can be trees, extended trees, or graphs along the z-axis of a 3D space. And to be able to compare the layers and annotations, there has to be a normalization of the positioning of the individual annotations, and this could be done in tree manner, mainly focusing on the hierarchy, or on text, on the basis of the spanned text. So if you measure the position on the basis of the spanned primary data text, you get a very different visualization. That also holds for the vertical normalization. Yeah, I will just show it. So this is what it could look like. You have a 3D space and the annotation layers, which correspond to the annotations here in the extend-off instance, and the positions in this case are based on the spanned primary data text. So this node corresponds to two elements because both of them span the same primary data text. Here you see the difference between the two normalization methods. The first one is the dominance perspective, just focusing on the hierarchy of the annotations. The second one, the containment perspective, focusing on the spanned primary data text. So what should be realized in the 3D approach? There should be free user navigation. The user should be able to go into the 3D graphics and explore it interactively. The structures for the layers should be draggable to virtually merge annotation levels and see how they relate to each other. There should be mouse over effects for the information on spent primary data and information on annotations. And classic overlaps should be highlighted in the corresponding 2D visualization, also in the 3D visualization, but it's not been implemented yet. What's also not been implemented by now is the highlighting of other specific structures like distinct element relation, discontinued elements, and also there's no choice by now for displaying annotated or the plain textual content for a node. That should be realized also. So what does the prototypic 3D visualization include? It's based on an XSLT stylesheet model which transforms extent of annotation into X3D, and the X3D, which is XML code, is directly embedded in HTML5. I've also created a text player just for illustration purposes. You will see what I mean by this. So that's what it looks like. I will show you in the browser. You have a section for the SVG, displaying the annotations. You have a section including primary data and one for 3D. What you can do is mouse over the text and you see what's annotated at this character position. You can go over the 2D SVG and see what annotation corresponds to this visualization, this bar. For example, here we have a noun phrase annotated, and you see it starts at text position 25 and ends at 39. The same can be done in the X3D, and you see which annotations or nodes in the 3D visualization correspond to primary data and to the corresponding node in the SVG. The text player is just for illustration. It goes through the text and you see what's annotated at this position. Also, you can drag this and, as I said, virtually merge these structures and see where are differences. For example, here. I should have said that this is an example for PDP attachment, so there are two, this is an ambiguous sentence, and there are two annotations for the two, for the two, you know what I mean. So. Okay, this is another example. I won't show it online now, but here you see the feature of displaying overlaps. For example, here you have verse structure lines annotated and direct discourse quotations, and if you click here to display the classic overlaps, these are shown in gray, and you see there's an overlap in the annotations. I've done a similar implementation for the XML basic transcription format. XML is a system for the transcription annotation of spoken language and can be used to construct and analyze spoken language corpora. The Party2 editor, the XML basic transcription format is the storage format of the XML Party2 editor, which is shown here. You can annotate and transcribe audio recordings or video recordings. So this is what it looks like. There are some similarities to the extent of format. You have start and end positions pointing to a timeline, and the timeline references certain time points in the recording. However, there are different prerequisites and requirements than for the extent of format. The first one is, like I said, primary data is audio or video, so there's a time-based alignment with annotations, not based on character positions, but time. And the annotations, for example, include concurrent transcription tiers for multiple speakers, so there's no single linear text, but there are three, in the next example, three tiers of transcriptions, which are also aligned. These will be visualized as interlinear text, and there are also flat concurrent annotation tiers, so the XML basic transcription format does not include hierarchical annotation, but flat annotation. Though it is not intended, it's possible to create hierarchies. If you, for example, annotate sentences and part of speech, it would be possible to construct a relation between the spanned sentences and the words, and thus create a hierarchy. So the sample case is a transcription with 3 speakers, orthographically transcribed, annotation of sentences and part of speech, and the visualization includes transcription of speakers as interlinear text, the 2D and 3D illustrations, and an alignment and highlighting of the corresponding annotations when you play the audio recording. This is what it looks like. I'll show you again in the browser. Okay, you don't see everything here. So it's not a problem. What you see here, you again have a section for the SVG. This one doesn't look, you don't get such a good overview like in the extent of format example, because the speakers don't always speak simultaneously. However, there are certain overlaps, like here. But as you can see in the SVG visualization, you don't have an overview of the whole recording or transcription. You have a section for the transcription, showing the transcription of the 3 speakers as interlinear text. You can play the recording and the transcriptions are highlighted. Okay, that's not too good, but you see. Oh right, yeah.
Is your volume up on your laptop?
No. Okay, should work now.
And what comes to is your determination at all?
Okay, you can play the individual segments, and you can play
To actually
the whole
succeed. I mean, is that a sort of a message that you hope comes across to kids?
Okay, it's not. Because there's a restriction, the JavaScript which is working here just gets time segments in 0.25 segments, so it's not possible to accurately align the text in this case. Maybe it's possible to do some improvement in the JavaScript, but I think that's a major restriction of this approach. What you can see in the 3D visualization is that you have an overview of the whole annotation. At first sight, it's not very...
Thank you, Dan.
Kind of like merge these, and in this case what you see is which speaker speaks the most, or where the individual speakers speak. The big blue ones here are show that, for example, second speaker, Vic, talks about in this section. So to conclude, I've shown two approaches for the visualization of multidimensional annotations, one 2D approach and one 3D approach. One for extent of, which is an annotation format for textual primary data, and the other one for XML basic transcriptions, which in this case were intended to deal with audio primary data. The used technologies are XML, those input formats are XML, SVG, X3D and HTML5 are XML formats, as well as XSLT, the programming language to transform the input formats into SVG and X3D, and JavaScript is used to implement the highlighting and interactivity features. What should be done in future for the 2D, that is SVG approach, is to implement synchronized scrolling. Should be tested if this improves the overview, the overall overview, and the correspondence between primary data and SVG section. And for the 3D approach, the user navigation should be improved. For example, automated zoom and viewpoint changes to automatically take different views of the annotations of the trees. In general, the performance and the features have to be improved, and the visualization of specific structures should be tackled. For example, in the 3D approach, overlaps are not considered by now, or referencing mechanisms like anaphora could be possible to show anaphoric relations by referencing, displaying arrows from one node to another. And another thing would be a conversion framework to support more formats than extent of and the XML basic transcription. There are a lot of formats which could be visualized in this manner. Okay, thank you very much.
Okay, we've got about 5 minutes for questions.
I guess that you're talking about this, what you could do in this annotation is sort of delineate sections.
Right, yeah.
But are there relationships, is there a hierarchical relationships between these sections as well? I mean, you had like a syntactic structure.
Yeah.
Are they in there as well? Because you had kind of lines, but it didn't seem to be dependency.
Not necessarily, no. It's rather to, for example, to compare the individual layers. If you have ambiguity, you can compare different annotations and see where are the differences, or are they similar. And for example, for discourse structure, you could use it to, I mean, that would be another approach to annotate different texts and see are there patterns in discourse structure for certain text types. If you layer these structures behind one another, you could possibly see are there certain patterns.